Welcome everybody. My name is Mike Whitlock. This is Bart Coleman, and we're here to show you how we implemented IT change management at ERCOT using JIRA. ERCOT is Electrical Reliability Council of Texas. Whoa, what just happened there? We lost our slide. There we go. So that is us. Yay, we're back on track. All right, and so we run the electrical grid in the state of Texas. We don't own the power plants, we don't own the power lines. All we do is make sure there's enough power on the grid for all the 25 million customers in Texas. We also provide a marketplace where people can buy and sell electricity. So we're kind of like the New York Stock Exchange of the Texas electrical market. Since we perform these functions, we're highly regulated. We get audits all the time, and we have to do everything by the T because of this. ERCOT has a big IT staff, consistently mostly of software and electrical engineers. And since we have a big IT staff, there's a bunch of change going on all the time, both on software and hardware infrastructure side. And because we're so regulated, we have to document all these changes. So today we're going to show you what we did. First things first, our old system was just purely chaotic. We used BMC Remedy for hardware or infrastructure changes, and we used HP PPM to document our software changes. And I was the Remedy admin and Remedy developer, so that was my baby, and we don't use it anymore, thank God, no. But the big thing with these two tools was they weren't true workflow engines, and so at ERCOT, we basically had to change our business process to match the application, which, come on, people, that's insane, right? It should be the other way around. And also up there, I put Outlook and Excel because when we didn't go down the sunny day path, right? Like Remedy had task groups where it said, hey, do this, this, and this. But when something bad happened or it didn't file to the T, we couldn't document it in the application because there was no collaboration in the tool. And so we had to go outside of it with emails and IMs and all that. And so really, when we get audited 2 years later, they're going to say, hey, you had this request to build a Windows server, and we have a Linux box now, so why is that? And so people would have to check their email and everything to find out why it happened. Which brings us to user frustration. So user frustration, the thing I heard a lot was, hey, I submitted a request and it went into the black hole. Because these tools didn't have issue transparency. People didn't know where they were. They didn't know what's going to happen next. Who to call to say, hey, why isn't my server getting built? Or why can't I implement this code already? In this here, this is Mr. Brian. This is a real-life example. I did not just make this up for the presentation, so I used him. He had to make an emergency database config change, and so it had to happen right now. He talks to our DBA team, and they say, hey, you got to go fill out a remedy change ticket first before they do the work. Because they've been audited before, because they know what's going to happen if they don't have a request. So Brian goes out, fills out the remedy change, the whole thing, and submits it. It goes to our change coordinator, gets the queue, and they look at it and they say, hey, this is a software change, not a hardware change. You need to log into HP PPM and fill out a PPM request for this. So Brian goes into PPM, fills out all that information again, and submits it, which of course now it's a different change coordinator who manages that queue. So she looks at it and she goes, oh, Brian, hey, this is emergency change. You first need to go to Remedy and fill out a Remedy incident ticket because it's emergency change. So he goes to the third system and fills out all this information again. Oh, by the way, it's an emergency change. We need it done right away. And finally, cost. You guys can tell I'm a developer and not upper management because this is third on the slide. I care about what the tools can do, what people think of the tools, and then how much they cost. When I did this dry run at ERCOT, our upper management saw this and said, hey, just take those first two slides off and just have the cost as the third one. Because anybody out here who uses Remedy or PPM know how much it costs. And I wanted to put our support and maintenance, how much we pay per year on the slide, but our legal team said we couldn't. So I couldn't do that. So everybody was kind of together in the fact that we need to do something different. So what do? Well, we go down the standard ERCOT path of, hey, let's get a new application. So what do? Business rights requirement doc. We send it off to vendors. We get RFPs back, and we have the dog and pony show come in and try to wow us. Well, this started in March of 2013, and by April of 2014, we were sitting in a room. We had 6 vendors come in, and we were basically trying to decide the lesser of 6 evils because nobody wowed us. And so it was like, well, they can do this, but they can't do that. And that's when Bart, who was our JIRA admin at the time at ERCOT, went to our director and said, hey, let's use JIRA. It's a true workflow engine. It has collaboration tools. Let's try it. And our director, who had past experience with JIRA at a previous job, said, you know what, you're right. And so he challenged Bart and I to write a proof of concept. We did that, hey, in 5 days. 5 days later, Bart and I had a working POC that we demoed to the project team and the IT upper management, and we finally wowed them, and they were like, yes, let's do this. So everything's great, right? But wait, we're so regulated, we can't just go forward with that as a capital project. So we have to have our board approve it. So the board says, hey, you got to bring in a third-party independent company and have them go through the whole requirement doc and see what JIRA can do. Because the whole time Bart and I are like, hey, can JIRA do that? Yes. They wouldn't even get the sentence done, and we'd be like, yes, it can do that. And so we bring in Precipio. Precipio goes through all 100-page requirement docket and says how much JIRA can do, did a gap analysis of what JIRA can do and what JIRA can do. The results, one minor limitation is all they came up with that JIRA couldn't do. And I say minor here because all this is that an issue can't get assigned to an individual or to a group, not just, it can only get assigned to an individual. But this should be 0 because we've worked around that, and we actually have triage working now where we have an individual JIRA user with a group distribution name and group distribution list. So based on the requirements, we came up with this high-level view. And we'll kind of go through this. Basically, first things first is we have the request for change. And so that's where people go to request what they need. And then it's either going to go down 2 paths. It's still going to go down the hardware path or the software path because it's 2 different actual processes. And to look at this, we're going to do this in 3 tiers. First things first, we have the request for change, which I call that the user. Because I don't care what you want. Do you need a new VM? Do you want code change? Whatever you have to do, you just go to this top level request for change and enter what you need. And that's it as a user. This second level here, I call it the bureaucratic because that's where we have to have all the approvals happen. At ERCOT, as an end user, I can say, hey, I want to install HipChat. So I need 3 new VMs. I want one for dev, for iTest, and for prod. And so I can just go in there and request that, but we have to have a document for each actual change that happens at ERCOT. No matter if we're adding a line of code or if we're standing up a new VM, at ERCOT, we have to have an approved document for all that. That's how regulated we are. And so we come in here, this will be a separate issue type, we'll go through this whole thing, and then down here is the actual work, which will be a subtask if it's software, the actual implementation happens. Here I just put 3 examples I have installed, decom and modify, virtual server, but really at ERCOT we have 108 here that will actually have its own workflow and everything, and we'll kind of walk through this. So what I'm going to do real quick, is we're going to actually go down this path and we're going to pretend like we're at ERCOT and we need 3 new servers to install HipChat. And we're just going to kind of walk down this path and go down it. And I'm basically going to be like driving the car, and when we did something cool, I'm going to stop and say, everybody look out the window, look what we did, look what we did. So that's kind of what we're doing here. So we need 3 new servers. All we have to do is go to JIRA, go and make sure the project's IT change management. This is the only issue type that the end users have rights to see. That's all they can see, even though we have 111 issue types, that's the only one they can see. So they'll come in here, and the request for change, you only have to fill out 5 fields are required. Summary, description, obviously, and then these 3 fields here. Now what we do is based on the answers of these 3 fields here, we will route the change, this RFC, down the hardware path or the software path. And so we come in here, and we do that with conditional workflow. So we're still on the request for change. This is our request for change workflow. Nothing special here, nothing crazy going on. All the magic and the meat and potatoes in this thing is in the conditions, validators, and post functions in this workflow. That's where we do everything. That's where we're driving. If you look out of this open, there's actually 5 different paths that come out of it, but the end user will only see 1 button, 1 submit, and that's based on our condition, how they answered those 3 buttons. So you come here, and this is how we actually do it. We just have on this 1 submit, we're doing the install 3 VMs. So we're based on our answers, this is a 5 nested condition. It has 3 ands and 2 ors. Based on the answer, is going to give them the button that they need. So on ours, it's going to send it down the hardware path. Now, like I said, we have the request for change, and everything now, we need a deployment request for each one of those. And so we need to link a new issue. Now, we're not going to have end users actually go out there and create a new issue and link it. And so you're looking right now in the request for change. It's in our service delivery review right now. And so that's the team that goes out and says, hey, since it's on the hardware path, hey, can our infrastructure handle 3 new VMs? You know, do we have the capacity for it? And so they say, yeah. What they'll do is they'll have 2 options here, auto create DRSD and approve. And if you look at the actual workflow here, auto create DRSD just stays the loop in the same status. In service delivery review, well, actually, you don't see it. Bart must have made this slide. It's supposed to see it where it goes down in implementation. So, thanks, Bart.
I'm a JIRA guy.
So we're going to look at if they need, like for our example, we needed 3 new servers. Our service delivery team comes in here, they will click this button 3 times. What we do is we clone this RFC and then just move it to the issue type of deployment request. So all the information they put in there will be in all the deployment requests. So 3 boxes for HipChat, they're all probably going to be the same. You need 1 core, 2 gig of RAM for all of them. You can put that in the RFC. That will automatically go down to all 3 of those independent separate requests. And see, what we do is we just have a Groovy script that clones the issue and moves it over, and we execute that on the post function using Script Runner plugin, which is awesome, by the way. Those guys are here. And then here's the results. You can see now in our request for change, we have 3 deployment requests down here, 1 for each environment linked to the parent. Now, everybody here knows, hey, JIRA works well with the parent request and subtasks. You can have subtask blocking. There are good relationships here. But for linked issues, it's just kind of a straight relationship. That's it. So you can do whatever you want with one issue, and it doesn't really affect the other issue. We couldn't do that here. What we had to do is we had to have a status blocking here. And so now we're actually looking at the deployment request. If you're in here, this thing is created, and it goes to the reporter of the RFC when that team hit auto create DRSD. But if you look up here, all they can do is cancel. And if we pull up the actual workflow here, you can see, hey, they should have a submit right here that goes to in-CC review, but they don't. And the reason that they don't is because we wrote code that goes out and checks the status of the related or the linked RFC and makes sure it's been in implementation. So like on this example here, the reason we do that is because to create the request for change, you're just generally saying, hey, I need 3 new servers, so let's create the request. When you're actually in the deployment request, that's where you have to put all the information that's required to actually submit a server build. Like, hey, what VLAN is it going into, all that other information. And so what we do is, once the service delivery team clicks that button, this goes to the reporter. Now the reporter, that RFC, can go and start putting more information in there. So we're not at a bottleneck of, hey, we're waiting on this team to actually approve it before we can actually start moving on and add information. So we eliminated that bottleneck here by doing this. And how we did it is we just wrote a Groovy script and put it into a condition that goes out to the RFC, finds the status or finds the linked issue, which is the request for change, make sure it's in that status. If it's in implementation, so let's say the service delivery team actually went in there and transitioned it, said approve, now our end users will have submit button. And that happens, you can see here, because the linked issue is now in implementation. And so the reason we do that is, like I said, because we have so many required fields on the deployment request, all what we need to do. And when I say a lot of fields, you guys may not believe this, but it's 16 to 70. That's not a typo. Bart didn't do this slide. I did this slide. It's actually 70. So based on your answers in the deployment request, when you pick your answers, like if you said, hey, change tested equals yes, then we have another field down here. What's tester name is now required. So you can have up to 70 fields. So we want people to start putting that information in right away. Now, having this brings us to a big thing. We can't just make these JIRA required fields, because as everybody here knows, if you make it JIRA required, you get the great red star, but you can't create the issue without having information in there. And so if we look at this issue here, we're in the actual deployment request here, and the user has submit. So they come in here, and where we make them required is on a validation on the transition. And I'm sure a lot of people have used that already. So when we move on, they come in here, they hit submit, and what do they get? They get this. I'm sure people here have seen this. Hey, these fields are required. You have to do it before you move on. And so what do? You hit close here, and then you hit edit, right? And you're back to this screen, and what do? Okay, I know asset impact was required, asset name. Oh, crap, what was the third one? Oh, hell, what was the 64th one that was required? And it's not like press your luck, people. We don't want our end users come in, start filling them out, hit update again and say, okay, I got the list down from 15 to 5. So what we did is we wrote JavaScript to actually put the red star on fields that are just conditionally required. And so when the end user comes in to edit now, they'll see this red star on test description. But you can tell this isn't a true JIRA required field, because it would have to have information in here just to create the issue. And we did that writing JavaScript and put it in field description. Now, we have heard that in future versions of JIRA, they're going to not allow JavaScript in field description. We're already ahead of that curve. We've prepackaged it into a plugin and installed the plugin, so we're on top of it there. And so just to give you an example, oops, Just to give you an example, I wish I had the cool video like at the keynote that the founders had, but we did not have that. So on this thing is real time too. So on this projected service outage here, you can see it's none, but these two fields below it are not. If the end user comes in here and changes that to yes, these red stars will appear right away. If they go in there and change the drop down to no, then the two red stars will go away. Next, approval process. We do is we add a subtask and we just link it to the deployment request. And what we do is we take the actual request for change, or the actual deployment request, you can see it here. Right now it's in our CAB advisory board review, so it's basically there for a review. Once they have the CAB meeting and CAB says, hey, yeah, go ahead and go do the change, they give the thumbs up for it, our change coordinator team will come in here and transition this. Now, you can see here we have approvers on the right. We automatically populate those using a Groovy script just based on information the end user puts in functional area and information type and what environment's going on. And it's basically what they did before. They had a spreadsheet saying, hey, if it's this, add these people. And so we do that for them automatically. So they come in here, they hit CAB agree, and they get a transition window. And we're going to put those people in there. Now, that person can always come in here, like Steve Daniels, Fisher, and Teresa Moody. They can take somebody out, add people in there. Whatever they need to do is what they can do. Who's ever in this list, when that person hits CAB agree, will automatically create 3 new subtasks assigned to those people, and it's pending approval. And it has all the information from the deployment request. So if we look at Steve Daniels here, he's the first one. When he actually goes into he gets the email or sees it on his dashboard, he doesn't need to drill up to the parent, to the deployment request. He doesn't need to go to the RFC or anything. He has all the information right here. So he can just look at this one shot and then click approve or reject. And we have subtask blocking. So the deployment request cannot move on until all the approvals have been approved. And once they do, then the deployment request fast tracks to the next issue automatically. So there's no bottleneck waiting for anything. Once people actually click it, we're going forward. We also have an escalation. So if we get to like a certain time that it's gone since these people haven't approved, we add a comment to the issue so they'll get that notification as well. Now, at ERCOT, we're a one fail or a one reject shop. So we don't care if we have 20 people as approvers. 10 people can say yes, but if one person says no, that rejects the change. And so if Steve comes in here and actually clicks reject, we wrote Groovy script that not only does that, it'll fast track the parent back to a CC review, but it'll also cancel any pending tasks. So now John Fisher and Teresa Moody don't have to actually go into their subtask and cancel it like before in our old tools, or it really wasn't them, it would be our change coordinator would go in there and cancel the open task. That doesn't have to happen anymore. We go out there and cancel it and add a comment on here when we cancel, so they get an email saying, hey, you don't need to cancel, or if they go off a dashboard, the item just goes away from their dashboard. And what we do is we move the parent back to NCC review, our change coordinator review, where they can, hey, go make changes if they need to, or send it back to CAB, or just flat out reject it. All right, transitions. So, like I said, we're kind of going down the path where we requested 3 servers for HipChat. It went to our service delivery team. They put the 3 deployment requests, then we put the information in. Now we have all their approvals. Everybody is approved. The work hasn't started yet. Like I said, if I haven't told you before, we're highly regulated. So it goes into this final CCC readiness check. And what that says is, hey, has there been any events or did our data center burn down or anything happen where, yes, everybody said approve, but you should not do that yet. And so they have a final check. But this was a huge bottleneck for us before because we have this field called implementation start time. And so this says, hey, we're going to start on the 22nd. And so the change advisory board said, hey, yes to starting on the 22nd. All the approvers, when they did their approver subtask, said, yes, started on the 22nd. When this person comes in here and clicked approve, the work would start. And so this team here would actually have to wait. Oh, let's wait till the 22nd. Can't click that one yet. Or set up a filter to wait for that time. And then what happens if, hey, this person went to lunch. They're not back till 2 o'clock. Yeah, we take long lunches at ERCOT. They get back at 2, and then they forget to click it. And we've just wasted time, and it's a bottleneck there. And so what we did is we changed this workflow. You can see here. There's 2 lines here, but the person on this team will only see 1 because we have conditions. If this time is in the past, when this team comes in here, they see approve. When they click approve, it'll go right to in implementation. The work will begin. The guys will start building the server. If this is in the future, like it is now, today's the 4th, and this is the 22nd, they can come in here. They can click approve, but it'll go to this new status called pending implementation start time, and it'll just sit here. And what we do is we have a service that runs in the background every minute that checks this status and this time. And if we get to one where the status is this time is past current time, and in the status, we automatically transition it to in implementation, and the work can begin right when it's supposed to, like right when it's been agreed to start. So now we're going to actually look at the work, the guys doing the work. And so on our example, we're doing install virtual server Linux. And so you look here, we have a cascading select in the actual deployment request, and it has 108 choices here. And these are our 108 issue types that have their own, they all have their own independent workflow on what we're going to do. And so based on that, when everything's approved, we have a new subtask that's added down here called install virtual server Linux. And it goes right to the network guys to start work, and it goes to the first status, which is IP switch port assignment. So those guys can start grabbing the next IP and start this VM build. And so looking at the actual workflow, this has been huge for us as well. And the reason why is because now this subtask has its own workflow. It's a real workflow. It's not like Remedy when we had task groups, hey, do this, next do that, do that. Because what happened is the network guys get it, right? And so they put the IP address in there. Well, guess what? People make mistakes, and so they fat finger the IP. The next step goes to our Windows guys for DNS entry, and so they try to go, oh, that IP doesn't ping, because the guys put the wrong IP in there or something. And so what happens is before, they could not send it back, or they couldn't do anything. And so they would have to call or IM or email the network guys and say, hey, go fix this IP that you did wrong. Great, right? But then what if the network guys forget it? But even bigger than that was our IT director, who's over service delivery, who used to be a database administrator himself, is really good at writing queries, has wrote our whole SLA program himself based on queries. And so what happens is he sees this thing sitting in the Windows guys team. It's just sitting there and sitting there. So he's calling the Windows guys, bitching at them, saying, hey, do your job. And they're like, hey, it's not us, you know, it's network, it's network. Well, first of all, it doesn't really work like that. They have to look in their email and say, hey, how come we didn't do that yet, you know? Oh, yeah, it was a bad IP. And so then they have to say, hey, call them, don't call us. Well, here this is an actual workflow. And so now if it comes down to our Windows guys and the IP guys fat finger the IP, they have a button to send it back. It goes back up to them. They have a screen where they can add a comment, and everything's in the issue. So we have all the collaboration there. And so first things first, our IT director, who you don't want the call from, is calling the right team saying, hey, do your job, which they should be calling the network guys and not the Windows guys. And plus, as the end user, this is huge for end users because now they know where it's at and what's going on with this. Before, they had no idea. They're just like the IT director saying, hey, guess the Windows guys aren't doing much here. They must be on that long 2 o'clock lunch. Okay. Next thing we did is we automated all virtual server builds at ERCOT. And so this is for Windows, Linux, and AIX. And so you can see here, this is where we were, that IP switch port assignment for the network guys. Once they actually claim the next IP in line, they'll enter it into the issue, and they'll hit complete. This happens on the transition. When they hit complete, what we do is we package up all the information in the issue and send it directly to Microsoft Orchestrator. And that's all the information in. Cores, RAM, drives. So like here, this is a Linux box. We're going to have our app drive. We're going to have a root drive. Everything that's in the issue, we take all the information, package it up, and send it to Orchestrator. Orchestrator just starts a Puppet job and starts the build. And then we go to this automated build in progress status. And you can see that here. I took a screenshot of one that was actually going on. It was in the status. We give the end users this transition here, check build status. So while the build is actually happening, they can click that and they'll see right here what's going on. So when I clicked it on this example, it was actually creating the DNS entry Puppet was. And at any point of the Puppet run, whenever they click that, we just make a REST call to Puppet, find out what they're doing, and put it right here in the issue so people always know what's going on. When Puppet finishes, no matter if it fails or it succeeds, it will automatically transition this to the next issue. And so this one here, this one succeeded, so we go right it was built, it was hardened, it goes right down to add enable for our system management team, and they can go out and start now add monitoring on this. If it fails, it will automatically transition it to this new status build fail, which is assigned to our Puppet guys automatically. And we add a comment down here. This one builds successfully. If there's an actual error, it'll give the Puppet error right there. And so now our Puppet guys, they'll get all the information right there or in the email because it's a comment and go right in Puppet, make the change, and then they have a transition here, execute job again, kicks off the job again, and there we go. Next thing we did is we automated CMDB population. So basically at the end of all those 108 workflows, we had a team that would look at what happened in the issue and say, okay, oh, they increased the RAM, so they would go out to the CMDB and make the change. Come on, people, it's 2015. Who does that? Nobody. And so what we did is we automated it. Basically, when it transitions down to this update asset inventory, we package up all the information in the issue. And this time, we send it out to our information bus, which at ERCOT is TIPCO. So we just send it up to the bus. And then our CMDB guys, they just listen for that event. They can grab it from the bus and populate it. And so it's different. It's different than the automated builds. For the automated builds, we package it up and send it right to Orchestrator because that's the only person who needs to know about it is Orchestrator. This is different. This is a CMDB change, or this is a change. And so our compliance department, they can be listening for event too. So if we do like an install, they can listen for an event off the bus and say, oh, hey, they just installed a new server. Let's make sure we add our update whatever they do. I don't know what they do. And like I said, this is just a screenshot from the actual plugin showing us we just trigger on the actual status. So when this thing comes down to asset inventory, we actually do the job. And so, results. I got 3 minutes. All right. So, oh, wait. Let me explain this before I actually show you the results. I couldn't just do a, hey, start to end from our old system to our new system. Because like I told you before, in our old system, we had to change our business process to match the tool, right? Well, guess what? We did that, but that other stuff that couldn't fit in the old tool still happened. It happened outside of the tool. Now in JIRA, we're able to take all that happened outside of the tool and put it inside of the tool. And so, hey, from start to finish, it's not apples to apples. But there's two things I can do apples to apples. And the first we're going to look at is approvals. Because all I'm doing here is tracking from the time the approval gets assigned to the person to the time they hit approve and reject. In JIRA, we've decreased that by 18.4 days. And you look at that and you're like, well, all they're doing is approving it. But in our old tools, in Remedy, when you get an approval for a change issue, it doesn't happen in the change. What happens is you get an email saying, hey, you need to go approve this. Well, you have to log into Remedy. You have to go to your approver console, which all it has is a bunch of numbers, your change numbers. Then you got to grab that, actually go into the change system, look at the details of what it is, go back to the approval system and click approve, where I showed you before in JIRA, right from the email, right from the dashboard, they have all the information there. Click to approve or reject, and there you go. The other thing I can do apples to apples is when the actual work starts. So like when the network guys got that first task of IP port assignment to the time that CMDB was updated. Now, yes, we've made improvements. We've automated the virtual server builds, but that was for 3 of them. For 95% of the other workflows, it's one-to-one. So Remedy, we had 12 tasks. Well, in JIRA, we have 12 statuses that we go through. But just by using JIRA for that, we've cut that down from 14.1 days down to 5.8 days. And not only that, but within 3 days, 61% of the builds, and it's not just builds, it could be anything, any job that's going through here, any of the 108 are done within 3 days. And what that means is, hey, before, if you requested something and you say, oh yeah, I got HipChat, I want to install, I need 3 new servers. Well, guess what? A month later, you can actually do it. A month later? Are you serious? Now we can do it. Hey, you want to install it? By the end of the week, you're going to have your servers where you can actually do it. And so what's that mean for our users at ERCOT? That's Brian now. They're happy. So real quick, because I know I'm almost out of time. What's next? Next thing we're going to do is upgrade our CMDB integration. Right now, all we're doing is taking the information from JIRA and sending it over to the CMDB. We're going to start pre-populating it. And so if you go into a request or an issue in JIRA and say, hey, I want to change the memory or something, and you put in a server name, we're actually going to pull the information from the CMDB and populate that issue. Next one, service desk. We still have Remedy incident. We're going to kick that the hell out the door and get a JIRA service desk project to replace that. And Just to let you know, right now, we still have Remedy incident tickets, but what we do on our team is we have a little button that says create JIRA issue, so we click it, it just closes the incident ticket and creates our issue for us in JIRA. And finally, because I got 5 seconds, I'm gonna go drink a beer because I actually made it through the slide without passing out. Thank you.